right, for this FRQ, it says the Taylor series for a function f about x equals 1 is given by the sum as n goes from 1 to infinity of -1 to the n plus 1 times 2 to the n over n times the quantity x plus 1 to the n, and converges for f of x for absolute value of x minus 1 less than r, where r is the radius of convergence of the Taylor series. For A, they want you to find the value of r, and since this series is not immediately geometric, we'll just need to use the ratio test. So it doesn't say to explain or anything. So normally we would say we enforce the condition of convergence of the ratio test. For this problem, you could, or it didn't especially have to, it didn't say to justify. So, all right, so limit as n goes to infinity. We'll just do the n plus 1 term. Just replacing all of the n's with n plus 1's. I probably should turn this into a single fraction. It's easier to keep track of what's what. So we'll do 2 to the n plus 1 on the top, x minus 1 to n plus 1, then over n plus 1. All right, you could divide by a sub n or just flip and multiply. I'll go ahead and flip and multiply. And we're finding the radius of convergence, so we're forcing this to be less than 1. Now it's just a matter of simplifying this down, figuring out what cancels, what doesn't. And I hope it makes sense. This -1 right here, since it's in the absolute value marks, it's a goner anyway. So you could keep that -1 in your work, or it could disappear either way. Now, as far as the limit is concerned, you could factor out the 2 and the absolute value of x minus 1. Notice that I went ahead and saved myself some writing and factored the 2 outside the absolute value marks. Like so. Now, evaluating this limit, you'd end up with +1, and so you'd be left with 2 times the absolute value of x minus 1 being less than 1. And then from here, just divide both sides by 2. There we go. And they only asked you for the radius convergence, so there's no need at this point to check endpoints or anything like that. So there you go. The radius of convergence is 1/2. All right, I think we'll go ahead and do part B and C, and then we'll come back and talk about squaring. All right, for part B, it says find the first 3 non-zero terms and the general term of the Taylor series for f prime, the derivative of f, about x equaling 1. So the first thing I would have you do is expand the sigma notation. So they told you in the beginning that f of x is defined this way. And so I would recommend that you expand that out. So if you do, you would get 2 times x minus 1 minus 2 times x minus 1 squared plus 8/3 times x minus 1 cubed plus -1 to the n plus 1 times 2 to the n and x minus 1 to the n, etc. So then from there, just taking the derivative can be pretty simple. So taking derivative of your linear term would give you 2. Taking derivative of your quadratic term would give you 4 times x minus 1. Derivative of the cubic term would give you 8 times x minus 1 squared. Now the derivative with respect to x of the general term, you'd treat everything else as constants. And so you'd end up with -1 to the n plus 1 times 2 to the n over n times x minus 1 to the n minus 1. You, of course, can simplify that by canceling the ends out. So I'll just write that a little bit neater. Like so. Okay. And that was what they were hoping for part B. All right, moving on to part C. It says the Taylor series for f prime about x equals 1 found in part B is a geometric series. Find the function f prime to which the series converges for the radius, basically for the interval of convergence. Use this function to determine f for the interval of convergence. Okay, well, let's look and see. So I'm just going to go back up here and notice. So f prime of x, if you look at this, it's geometric. What is your first term? It's 2. So first term. What's your common ratio? It is, looks like they're multiplying by -2 times the quantity x minus 1 every time. There you go. All right, so what does that mean? That means that f prime of x would sum up to be your first term divided by 1 minus your common ratio. There we go. In the spirit of the person you're simplifying for is yourself, I do recommend you simplify that. So what would that be? 2 over 2x minus 1. Now this is only true though, my friends, if the absolute value of your common ratio, is less than 1. Which, by the way, simplifies to be here we go. Exactly what we had in part A, which is what they're talking about here. Okay. Now they said to use this function to figure out what f was. Well, what do you do to f prime to get f? Yeah, you take its antiderivative. So f of x would simply be the antiderivative. Like so. So you could, let u equal 2x plus 1. What would du be? It would be 2 dx's, which is great because I've got 2 dx's. So f of x at this time looks like it would be the natural log of the absolute value of 2x plus 1 plus c. Now for what plus c is, you can use an initial condition, and I would really recommend where everything was centered. So just a quick note, actually, I don't want to rewrite it, but maybe I should just rewrite it. It's easier than erasing with this pen. Okay, anyway, let's see. Since this is f of x, think about what f of 1 would be. So f of 1, I like the expanded out version personally. F of 1 would have been just replacing all the x's with 1's. And so what would f of 1 have been? I hope it makes sense. F of 1 would have been 0. So you also could have used sigma notation. You would have gotten that you're adding up infinitely many zeros also. So the point is that f of 1, if you use that initial condition, you'd get that f of 1, which would look like, let's see, when x is 1, you end up with, do I have, no, oh my goodness, I have a typo. And my eraser doesn't work. Okay. These should be minus 1s. There we go. All right, there we go. Okay, so if x is 1, you'd end up with 1 there. And since natural log of 1 is 0, that means c is 0. So your final answer would be that f of x is particularly natural log of the absolute value of 2x minus 1. There we go. All right, let me change the color and then we'll talk about scoring. All right, going back up to part A. Part A, they're going to give you 1 point for setting up the ratio. So in my work, that would be that part inside the absolute value marks. Again, you could have had that as a compound fraction as well, as long as it is equivalent to that mess right there. So 1 point for that. 1 point for determining the limit of the ratio. And that would be basically what you got after you simplified the left side. Determines limit of ratio. That's that. And then the last thing would be getting the radius of convergence, which shows up here and here. There we go. Okay, now for part B. Part B, they're going to give you 1 point for getting the first 3 non-zero terms. And then 1 point for the general term. All right. Part C, they're going to give you 1 point for getting f prime, whether you simplified it or not. So you also could have left it like that. But 1 point for getting f prime. And then 1 point for getting the antiderivative. That plus c would be necessary. The absolute value marks as well. And then the last point is for getting f of x correct. Absolute value marks and all. There you go. Hope this adds up nicely for you. Take care, everybody.